Hello. Today we're starting a new unit. It is 3.1. We're going to start graphing in this unit. So we're using linear equations, which we used in the last two previous units, but now we are going to put them onto a graph. All right. Okay, so it says we will plot ordered pairs, determine whether an ordered pair is a solution, graph linear equations, and graph nonlinear equations at the end. Linear just comes from the word line, and non means no, right? So a linear equation means that if I graph, and it's okay if you don't know what that means yet, if I graph this equation, an equation is anything with an equal sign, 2x equals y, x equals 5. Anything with an equal sign is an equation. So a linear equation, if I graph x equals 5 and it's a linear equation, that graph will be a straight line. Okay, so if it's a non-linear equation, it might curve, it might do something like that, have a sharp turn in it. That would be non-linear. It is not a line, a circle, something like that. Okay. So when we are graphing, we graph on a plane, but it's spelled, is it on here anymore? The rectangular coordinate system, you can just say is a plane. P-L-A-N-E, okay? It means a flat surface extending forever in 4 directions, okay? A plane is a flat surface. A plane is a flat surface extending forever in 4 directions. Here are the 4 directions. So when we see a plane or a coordinate system, or you think, or we're talking about graphs, imagine this, okay? Imagine something that looks like that. That is what we are talking about. Okay. Graphing just means finding something, finding a location on the plane, right? So if I'm graphing linear equations, it means I'm putting a line onto, oh, it's too small. I'm taking that line and I'm putting it onto this plane, okay? Or we can just put a point or an ordered pair on the plane as well, okay? We break, let's just look at this. So here's our plane, right? This whole thing is a plane, and the plane is where we graph things. An ordered pair is 2 numbers associated with a point on the graph. So the ordered pair here is 0, 0, right? That is a place on the graph. 0, 0 is a place on the plane or a place you are graphing. Okay, and it's called an ordered pair. How do we know this is 0, 0? Because we added lines to the plane to break it up, okay? We break up a plane using lines these are number lines, right? They look just like number lines. So we use two number lines. Just draw an arrow since I put that S there. We use these two number lines to break up the plane so that we can describe where a point or an ordered pair is on the plane. Okay, so what we have covered so far is what we are doing. We are graphing, and we are determining whether an ordered pair is a solution. So when they say ordered pair, I want you to think parentheses, x comma y, but those can be any number. So I'm going to say 2 comma -5. Okay, that is an ordered pair. I also call it a point because it's basically just a dot on the graph, right? A point is an ordered pair, two numbers associated with a point on the graph. The first number gives the horizontal is like horizon. The sun comes up over the horizon location of the point. The second gives the vertical location of the point. So vertical always means up and down. Horizontal always means left to right, like the horizon, okay? So this guy's horizontal. That is vertical, okay? So I made up a point, 2 -5. The first number in my point or in my pair gives me the horizontal location of the point, okay? So I use the x-axis, this number line. This would be the horizontal number line, right? So I made horizontal purple. We'll say this is we'll say this is horizontal. Okay, so the x always thinks is flat, all right? And then we said that the vertical was green. So the y-axis is vertical. It goes up and down. Okay. These are just two number lines. One is going this way, the other is going this way. And we use those two number lines to explain a place on the plane or on the coordinate system. Okay. So I gave you the point 2 -5, right? Let's write it like this. Where would 2 -5 be? It says the first number gives us the horizontal location of the point. So if this is a number line and we know this is 0, 0, so that is the origin of the number line, where would 2 be? If it's a +2, we need to go right, right? So 2 on the horizontal or on the x-axis, and then we said -5 on the vertical axis. If this is still 0, 0, we need to go down 5, right? 1, 2, 3, 4, 5. So where those two meet, +2, -5, that is one ordered pair, okay? And these can be any number, right? This ordered pair is 0, 0. An ordered pair is also a point, okay? So when we're looking at horizontal, horizontal is always x. vertical is always y. Okay. They help us to locate points on a plane. They intersect or they cross at 0, 0, right? They go positive to the right or positive up, and they go negative down, negative to the left, right? Okay. So ordered pairs are always in parentheses. You see how the 2 and the 5 are 2 and negative 5 are in parentheses. They're always in parentheses. The first value tells you how far to go on X. The second tells you how far to go on the Y-axis. So think of it like directions, right? Each point is a place. 0, 0 is also called the origin because origin means the start or the beginning, okay? Origin means where it starts. So I'll just write that. X-axis is horizontal. Y-axis is vertical. Okay, the origin is the point of intersection of the two axes. For us, that will always be 0, 0. Which means 0 on the X, 0 left or right, and then 0 on the Y, 0 up or down. So we did not move left or right, 0. We did not move up or down, 0, okay? Quadrants means the 4 regions created by the intersection of X and Y, okay? The quadrants are just something, it's an odd order, but it goes 1, 2, 3, 4. So it's just something to remember. Quadrant 1, quadrant 2, quadrant 3, quadrant 4. And these are Roman numerals. So the I means 1, I means 2, right? I means 3, IV means 4. Okay, 1, 2, 3, 4. So what else? Okay, so if I just made up another point, right? Let me make up a point. Let me make some points to graph in this ordered pair. Okay, to graph a point corresponding to, right? Or graph a point related to a particular ordered pair X, Y, start at the origin, 0, 0, and move X units to the left, the left if it's negative, or to the right if it's positive, and move Y units up if Y is positive, or down if Y is negative, okay? So let me just give us some points and we will practice graphing them. We already graphed 2, 5, right? Sorry, 2, negative 5. Forgot to put that little negative. 2, negative 5. Let's do 0, 2. And then we can do negative 4, 0. And negative 3, 3. Okay. So if I want to graph these, I always start at the origin. For 2, negative 5, I went over to, oh, okay. Sorry. So always corresponding to a pair X, Y. So when I see this, I often write X, comma, Y, because the first number has to do with the X-axis That's why we go left or right. The second number has to do with the y-axis. That's why we go up or down, and it will never change. The first one is always x. The second one is always y. X, y, x, y. Okay? So this is always x. This is always y. So x2, let me move this up a bit so we can fit it. All in the same shot. Okay, x2, y negative 5. And then I labeled it 2, negative 5. All right, x is 0, so I don't move left or right. y2. 0, 2. Okay. X negative 4. So I go 4 to the left. 1, 2, and then y0, so I don't go up or down at all. And then x negative 3, y3. 1, 2, 3. Negative 3, 3. Okay, so that's how I plot points. The first number I count on the x-axis, either negative or positive, or the x number line. The second number I count on the y number line, or the y-axis. Okay. So you can put the ordered pair with it, or sometimes it will give you a list and it will have letters. So if this was point A, you could just put an A next to the 2, 5. If this was B, you could just put a B here, okay? Oh, like this one. Okay, so each of these has a letter. So I'm going to plot the point, and then I'm going to add a letter next to it so you know which point is which. So this one says 4, the x is 4, the y is 2. So I'm going to go positive 4 on the x-axis, positive 2 on the y-axis, and then I'm going to put the letter A. There's point A. B is negative 3, negative 2. Negative 3, negative 2. That's point B. C, 2, negative 3. Positive 2, negative 3. That's C. D is 0, positive 4. E is 5, 0. Okay, and I know I didn't really talk about quadrants very much, but basically this is always quadrant 1. It's between positive x and positive y. Quadrant 1 is positive x, positive y. Quadrant 2 is negative x, positive y. And then we go down here like a clock. Is that like a clock? Is this clockwise? It's not. 3. Quadrant 3 is negative x, negative y. And quadrant 4 is positive x, negative y. So we can say D, point D is on the x-axis. That's what we call this number line, okay? Point, did I give you 2 Ds? It's supposed to be E. Point E is on the x-axis. Point D is on the y-axis. or the Y number line, right? And then the rest of them, you can label them by quadrants. Point B is in quadrant 3. Point C is in quadrant 4, okay? So that maybe better explains the quadrants, 1, 2, 3, 4. So before we continue, I just want to be sure we know our objectives. We know what an ordered pair is. An ordered pair is a point, right? We will learn this in this class. Graphing linear equations. We know what linear equations are, right? Graphing nonlinear equations means it's not a line. An ordered pair, an ordered pair is just these two numbers. Your coordinates are the numbers on the ordered pair, right? These coordinates are 2, -5. The x-axis is this line. The y-axis is this line. The origin is 0, 0. And the quadrants are the 4 regions when the axes, which is the same as this word, just plural, when the axes intersect or cross. Okay. We know how to graph. We graph the point corresponding to an ordered pair. Start at 0, 0, move x left or right. And then for the second number, move y up or down. Okay. Here's our example. And now we have plotted the points. Okay. So now we know what a quadrant is. State in which quadrant or on which axis the point lies. So now all we have is point A. Point A is in quadrant 1. All right, example 2. Determine whether, ooh, okay, now we got our final learning objective, okay? Determine whether an ordered pair, a point, is a solution. So we have an equation, because here's an equal sign, right? Determine whether, which means yes or no, is, right? Is 3, -2 a solution of 2x plus 5y equals -4. Okay? So when we graph, what we are really doing, we actually do it. When we graph, what we are doing is we are connecting points in a line. A line is a series of points. Okay, so on this line, each of these is a point. And you could get them so that they're so close together that there are infinite points. The points just make the line, okay? Each point has a location. So what we are finding when we look at this is the location of the point, okay? There are infinite, remember the infinity symbol? There are infinitely many points on a line, and each point has a coordinate, or each point has an ordered pair. Each point has a location, yeah? Because each individual point has an x value and a y value, we can make an equation using x and y for that value, for that line, Okay, so here's an equation, right? Here is a point, x, y. How do I know if this point is a solution for this equation? If I graph 3, -2, and I graph 2x plus 5y equals -4, will they be on the same place? Will this line cover this point? This line, yeah? This point is not on this line, but this point is on this line. So we would say this is a solution for this line. This is not a solution for this line. So right now they want you to tell them, is 3, -2 on this line if I put this line on a graph? Okay. So when a point is substituted into an equation and it makes it true, the point is on the graph of that equation. All right. So we just have 2x plus 5y equals -4. 2x plus 5y equals -4. How nice. We have an x, we have an x, we have a y, we have a y. So it says, substitute the point, put the point into the equation. The x is 3. The y is -2. Will this be true? If it is true, it is a solution. If it is false, it is not a solution. If it is true, it is on the graph. If it is false, it is not on the graph. So we know 2 times 3 is 6. 5 times -2 is -10. So I'm going to change this from +5 to -10 because it's a -10. Plus a -10 can also be written as -10 is -4. 6 minus 10 is -4. 6 minus 10 is -4. -4 is -4. Yay. So we determined that this point is a solution of 2x plus 5y equals -4. Right? They asked us, we answered it. Okay. There is one more thing you can do. At this point, you may check your answer. Okay. So I want to show you a website. This is called Desmos. So the website is desmos.com/calculator. Okay. It's looks just, this part looks just like what we had on our paper, the plane, and then with our x-axis and our y-axis. And what we do here to check our answers is you can just type in 2x, you can type in your equation, 2x plus 5y equals -4. Okay. And then you can type in 3, -2. This shows you that that this point is on the line, the graph of this equation. This point, you can also use Desmos just to explore graphing on a plane. What is x? Sorry, what is x? Ooh, if you just want to graph x, that's what the graph of x looks like. If you want to graph x equals 3, that's what x equals 3 looks like. Y equals 4 looks like that. Yeah, so you can start to understand what it means that an equation is a line. Sometimes it's not a line, but that an equation can be graphed. A lot of math can be graphed. It's a good place to explore. All right, go back to this. So we have determined it was a solution, and then we checked our solution. All right. Example 3. For example 3, you try. Is -1/6 a solution of 3x minus y equals 5? All right, so just what we did last time, might be a little bit quicker, right? So I always label x, y. All right, did you try it? 3x minus y equals 5. X is -1. Y is 6. Three times -1 is -3 minus 6. Is that true? -9 equals 5? No. -1/6 is not a solution of 3x minus y equals 5. Okay, and we can check that again with Desmos. Let me share my screen. Erase all of this. Erase the one part. All right, so our first one is, we could do the point first, -1, 6, right? I need, oh, there it is. And then 3x minus y equals 5. Those are not, those don't cross, right? -1/6 is not on that graph. So we know we were correct. A linear equation in 2 variables, same thing we saw here, a linear equation in 2 variables, the variables are x and y. Variable x and variable y. Is an equation that can be written in the form ax plus by equals c, where they are all real numbers. So this could be any number, but one of these is not 0, right? A and B are not both 0. It's called standard form. Okay. Graphing linear equations by plotting points. All right. Step 1, solve an equation for y. It just means get it so that y equals, right? This was standard form, but now we want it in y equals form so that it's solved for y. Choose 3 values for x. I choose easy ones, right? I like -1, 0, 1, because I want small numbers if I have to graph this. And I want to do math with easy numbers like 0. Substitute each x value into the equation and solve for y. You can use any 3 values you want. Plot the points just means put the xy on the graph and then connect the points, okay? So graph the linear equation. It means follow these steps. Solve for y. It is already solved for y. Excellent. Okay, so we've solved it for y. Choose 3 values for x. So I'm going to make that same table. I have x. I have y equals mx plus b. And then I have the coordinate point x comma y. So because there's a fraction, I'm not going to use -1, 0, negative, +1. I'm going to use 4 because if I'm multiplying, right? I'm multiplying by that number. And so if I multiply by 4 and the fraction has a 4 in the denominator, I'm making it easier for myself. I won't get a decimal or a fraction. Okay. Like we've been finding the least common denominator. Now we're going to use the least common denominator. It is 4, right? Because it's the only number that's in the denominator. I can still use 0 because that'll, that's also easy to multiply by a fraction. So numbers that are easy to multiply by fractions are numbers that are the denominator or that the denominator can be divided by, or 0. So we have y equals 3/4, and instead of x, I'm going to write the number 4 plus 3. Sorry, this is so small. Okay. Y equals 3/4. This time instead of 4, I'm going to put 0. 0 plus 3. Y equals 3/4. Oh, -4 plus 3. All right, so 3/4 times 4 just becomes 3. 3 plus 3 is 6, right? Y is 6. So now I have x is 4, y is 6. When x is 0, y is 3/4 times 0 is 0, plus 3 is 3. 3/4 times -4 becomes a -3 plus 3, which is 0. So -4, 0. So those are my points. And I'm going to now graph them. Okay. So my first point is x4, y6. Next point is 0, 3. And then we have 4. Oh, sorry, -4. Oh. -4, 0. Okay. And now you want to graph that to make sure it is on a straight line. Oops. If it's not, it's just because I didn't draw my graph very well. Right? So the linear equation y equals 3/4 x plus 3. Now I'm going to show you that this really does fit because I didn't draw my points well, but it will fit. So we'll go back to Desmos. this one. All right, so we have y equals 3/4 x plus 3, okay? And then our points are 4, 6, 0, 3, -4, 0. Oops. Okay. Graph the linear equation. That is what you are doing today. Okay. Next example. Graph the linear equation. 2x minus y equals -4. All right. So first, solve for y, because this is not in y equals form, right? So I'm going to go up here. I'm going to run out of space otherwise. Always do. 2x minus y equals -4. And I'm going to solve for y. So that means I'm going to move the x over here. And I want it in y equals mx plus b form. And so I want the x in front of the number without the x. All right. So now I have -y equals -2x minus 4. Okay. So I just switched those because I like the x in front of the number that is the constant with no x. -y equals -2x minus 4. But it doesn't, you can write it the other way. It will not be incorrect. Now I need to divide by a -1, right? I want to get rid of the negative sign with that y. So -y divided by -1 just becomes y. -2x divided by -1 becomes +2x. -4 divided by -1 becomes +4. So my equation solved for y is y equals 2x plus 4. Yeah. Now I'm going to make that table. Make it bigger this time. X, y equals 2x plus 4. X, y coordinate point. Again, I want easy numbers. -1, 0, 1. And I always want to do 3 to make sure that I can make a line, because with 2 points, you don't really know if you've made a mistake or not. But with 3 points, you're like, do those 3 points line up or do they not? You kind of know if you made a mistake or not. All right, so here we go. Y equals 2, but the x is -1 plus 4. Y equals 2 times 0 plus 4, or y equals 2 times 1 plus 4. 2 times -1 is -2, right? -2 plus 4 becomes +2, right? So the x that I'm using is this one, -1. And then the y comes from over here. -2 plus 4 is 2. So that's where I got those two numbers if I was going too quickly last time. Okay. So we know x is going to be 0. And y, 2 times 0 is 0, plus 4 is 4, right? And our last one, the x is 1. The y is 2 times 1 plus 4, so that's actually 6, right? 2 plus 4 is 6. Now, I just need to graph these 3 points. It's always up here, and I don't leave myself enough room up there. All right. On the x, all we have is -1, 0, and 1, right? But on the y, we have to go all the way up to 6. 1, 2, 3, 4, 5, 6. All right, so -1 on the x, +2, 0, +4, 1, +6. There's my graph. There's my graph. And let's see what Desmos says. All right, and let's look at Desmos. So here you can put in the equation y equals 2x plus 4, or you can type in 2x minus y equals -4. Y equals 2x plus 4. You see it's the same line. And then our points were -1, 2, 0, 4, and 1, 6. So those points are on the line. So my graph is correct because those are the points I graphed as well. All right. Intercepts are points where the graph crosses the x-axis and the y-axis. So we call it the x-intercept. When you find the x-intercept, y is 0. So this is the x, right? You are crossing x. So here is the x-intercept. Here's the x-intercept of that line, because that's where it crosses x. Y is equal to 0, solve for x. The intercept will be whatever number you got for x, and then y will be 0. Now for the y-intercept, here, excuse me, here is y. So this is our y-intercept for this line. This is the y-intercept for this line. And for the y-intercept, we set x equal to 0 and solve our equation for y. Example 6. Example 6 says graph 2x equals y by finding and plotting its intercepts. Okay, so let's find the x-intercept, just like the notes say. Okay. Find the x-intercept by making y equal 0. Okay. So it was 2x equals y. Instead, I'm just going to say 2x. Oh, sorry. So y equals 0, right? So 2x equals, I'm replacing y with 0. Now I solved for x by dividing by 2. Divide both sides by 2. 2x divided by 2 just gives me x. 0 divided by 2 gives me 0. Okay, so when y is 0, x will be 0. So my x, y intercept, or my point, sorry, my xy point is 0, 0. So you might be thinking, oh, if x is 0 when y is 0, the y-intercept is also just 0. So now we'll find the y-intercept by saying x is 0. Same equation, all right? 2x equals y. X is 0, so 2 times 0 is y, right? 2 times 0 is just 0, so 0 is y. So we know that when x is 0, y is 0, which is what we just said in the last one too. So our x-intercept and our y-intercept are 0, 0. They cross at this graph crosses at the origin, but we need more points, right? I can't make a graph out of 0, 0, because if I draw a plane, I only have the origin as my point, 0, 0. Where does my line go? This way, this way, this way. So I need at least one more point, probably 2, because if I can line 3 up, I know I haven't made a mistake if it's a linear equation. All right, so we have x, y, and then xy. I'll use the point, we can't use the point 0. I'll use the point -1. So y equals 2, and then I'm going to replace x with -1. Y equals 2 times -1, that's just -2. So y is -2. So this one goes in this spot. This one goes in the x, right? So my point is 1, comma, -2. All right, I'll do one more. Let's do 1. All right. Y equals 2. Instead of -1, we're going to say +1. 2 times 1 is 2, so y equals 2 when x equals 1. So now I have, oh, sorry, -1, +1. When it's +1, it's also +2. Okay, now I graph these. So remember, it goes x, y, x -1, y -2. X +1, y +2. All right, and then I turn that into a line that goes on forever. To show that it goes on forever, I just put an arrow on either side. Okay. Graph y equals x squared. So this is non-linear. Remember, linear means that the x is only raised to a 1, right? Here, x is raised to a 2, so it's not going to be a line. I don't know what it is, but I know it's not going to be a straight line through this plane. So if I graph it, first I just need a table, right? X, y equals x squared, x, y. I see that x squared, no, this is okay. Yeah. All right, I'm going to pick easy numbers, but I don't know what this is going to look like, so I might need more than 3. So I'm going to start with -2, -1, 0, 1, and 2. All right. So now we're going to say y equals -2 squared. What is -2 squared? -2 squared is 4. And the x was -2. So when x is -2, y is 4. -1 squared is just 1. So when x is -1, y is +1. 0 squared is 0. One squared is 1. And a +2 squared is 4. I almost said is 2. That would have been wrong. All right, you can check these in your calculator if you would like. -2 on the x, 4. -1, 1. 0, 0. 1, 1. 2, 4. So that is not linear. It has a 1 curve in it, right through the origin. That's what my graph looks like. And on Desmos, it was y equals x squared. So if I just say y equals x, that's a straight line because x is raised to the first power, but x squared, it becomes a curve. And then they intersect here and here. All right, so we know we did it. We know we plotted our points correctly. Let's go to example 8. Graph the absolute value equation. All right, how does absolute value, we know y equals x, we just saw it on Desmos, just goes straight through the origin, left to right, bottom to top, right? North, south to north. What about if I made the absolute value of x? Do you remember absolute value from last unit? It's always what? It will always be positive. So when I'm finding points for this, I want to use some points that are negative just to find out what happened to the graph, okay? Y equals the absolute value of x. So x is -2. Y equals the absolute value of -2. That means it's -2, +2, right? -1. Y is the absolute value of -1. That means x is -1, y is +1, right? The absolute value of -1 is a +1. When x is 0, the absolute value of 0 is 0. So it goes through the origin. 1, y is the absolute value of 1. The absolute value of 1 is 1. Absolute value of 2 is 2. Okay, and remember, you can use any point you want. You just this graph only goes to 7, positive and negative 7 for x and y. So it's kind of easy to use small numbers. All right, x negative 2, y positive 2. X negative 1, y positive 1. 0, 0. X positive 1, y 1. That's not a straight line. 2, 2. So it looks like this is not, right, a straight linear equation. It will never cross the x-axis, we call it. Okay. Example 9. Ooh, graph the equation y is the square root of x. What do we know about the square root? What can you not put under the square root symbol? You cannot put x, remember domain, x such that x is never negative under the domain. Okay. So we won't even try it. And we will look at what the graph looks like on Desmos afterwards. So we won't put any negatives in. I'll just start at 0. X, y is the square root of x, x, y. And you know what? If I have to square root x, I'm going to make x into a perfect square. What are some perfect squares? Well, we have 0. Y equals the square root of 0. So that will be 0, 0. The square root of 1 is 1, right? And then I'm just going to go. What's the square root of 2? 4. So the square root of 4 will give me x is 4, y is 2, right? Square root of 3 is 9. Or sorry, 3 squared is 9. So y is the square root of 9. X is 9, y is 3. Okay. And so just to explain again, this is from this number. And then the y is when I put that in for x, what y became. Y became 0, y became 1. The square root of 4 is 2. The square root of 9 is 3. So those are from these numbers. Okay, and we will graph it. 0, 0, 1, 1, 4, 2, 9, 3. Is that that's not linear, that's a curve. So you cannot use a ruler to graph that. And let's see if we can do it in Desmos. So delete that one. Sorry, I forgot to share my screen. All right, so y equals the square root of x. And, oh, if you push right here, you can look at the table. -2, undefined. There is no graph below 0. -1, undefined. There is no graph below 0. 0 is 0, 1 is 1, 2 is 1.41. So you can use any number, even a decimal, if you want. And you can put in your own value for x. Like what would 81 be? It would be 9. Way out there. Okay. All right, so those are all our examples. Thank you very much. I know this was a long one, but good job today.